So this is our notes on minerals and rocks. We're going to start with minerals, and because minerals make up all rocks. So all rocks are made up of minerals, and there's certain characteristics of minerals that all minerals have. There's five characteristics. The first is that they have to be naturally occurring. They can't be made in a lab or synthetically made by humans. They have to be inorganic, which means not made from living things. Organic means living, and in means the opposite or non-living. So they can't be made by living things. They're found as a solid in nature. They're formed from elements or compounds, and they have a definite chemical makeup or a regular atomic structure. So throughout the whole substance of that mineral, you're going to have repeating patterns of a chemical or atoms, and that helps us to identify this as a mineral. So water, oddly enough, water can be considered a mineral because it's naturally occurring, inorganic, not made from humans, or not made from living things, I should say, found as a solid ice in nature, formed from elements or compounds, H2O, and has a definite structure or makeup. Minerals are classified, we divide them up by their physical and chemical properties. And we're going to spend a lot of time looking at the different properties of minerals. And by using those properties, we can identify them out in the field or even in the laboratory. Color is one of the first things that's obvious. It's easiest to recognize. It's the easiest thing to see when you're looking at a mineral. But the problem with that is that it's not very reliable. And quartz is a really good example of that. Here's why. If we look at quartz, this purple amethyst, this white quartz crystal, these citrine quartz, smoky quartz, all of these are the same mineral. They just have different colors. So they have different colors, and so you can't just say this clear crystal is quartz just because it's white or it's see-through, or this purple one is quartz because there are other purple minerals out there, or brown minerals. So each mineral can have different forms, and many different minerals can have the same color or both be transparent. Calcite and halite both have crystals, and they both are clear to see through. So the idea is that color can help us, but can't be a defining characteristic. So quartz is a great example of that. Another test is something called streak, and streak is the color of the powdered mineral. And what you do is you take the mineral and you scratch it across a piece of unglazed ceramic tile. Sorry, let's see if I can get both of these things in here at once. So we take the mineral and we scratch it along a white ceramic tile, and that white ceramic tile will show what the powdered mineral looks like. So you might have a black mineral, and when you scratch it across the tile, it might turn brown or reddish color, or a greenish color. Many times, many of the minerals have a clear, no streak, or a white streak, and so we'll look at that in the lab as well. So the streak is just how the mineral looks when it's up in its powdered form, and we test that by streaking it across a piece of tile. The luster is how it shines, or how it reflects light. And we have two broad categories within this. One is metallic, where it looks very shiny, and one is non-metallic. Not shiny can be dull or waxy or glassy. Sometimes it's challenging to see whether something's glassy or metallic. Sometimes if you look at a piece of glass, it shines, but it doesn't shine like a metal. And one of the big characteristics that metallic minerals have that glassy minerals don't, not these non-metallic ones, is that metallic, you cannot see through them. So if you can hold it up to the light and see through it, then it's definitely not metallic. It would be glassy. And I'll show you that in the lab because it's a very obvious thing once you notice it. But you can see these metallic minerals. All of them have they're not see-through, but they're shiny, like a piece of copper or a piece of steel or a piece of brass. They're shimmery like that. Now the other types of non-metallic, they might be shiny, like this quartz, glassy. This biotite looks metallic in this picture, but I'll show you some examples in class why it's not metallic, because you can see through it. And this apatite, again, you can see through that if we had a decent sample of that. So those are some of the characteristics of the luster. So you can break them up into metallic or non-metallic luster. All right. The hardness is another characteristic of minerals. It's the ability to be scratched or be scratched. So what you will do is you'll take an edge of your mineral and try and scratch a glass plate. And if it scratches a glass plate, the hardness it means that that mineral is harder than the glass plate. And the glass plate is at about 5.5 on this, what's called the Mohs hardness scale. Mohs is he was a scientist. He was a geologist that looked at all these minerals, and he came up with a scale, and each one of these minerals on the scale is at each of these numbers. And so if you were to take talc or gypsum or calcite or fluorite or even this apatite and try and scratch glass, it wouldn't scratch it because these are all less than 5.5. If you take feldspar, quartz, topaz, corundum, or diamonds and scratch it against the glass, it will leave a scratch on the glass. It will leave a mark on the glass. And so those would mean that these are harder than the glass. And so you can use that. He used this as a scale to help him find what the hardness of the mineral is, because that can help us identify it, because the minerals all have about the same hardness. If you have a sample of apatite, all the apatites are going to be right around 5, and fluorides are all going to be at 4. So if I find a piece of mineral out in the wild and I take a piece of calcite and I rub fluorite on calcite, the fluorite will scratch the calcite, but the calcite will not scratch the fluorite. If I take the fluorite and I try and scratch apatite, it won't scratch apatite, but the apatite will scratch fluorite. So we use these common minerals because we can carry these around with us, a little sample, and we can use them to scratch the minerals. We can also, so here's an example of somebody with a piece of glass here. They're taking a piece of quartz and scratching along that glass, and as you notice, quartz is a 7, so it will scratch the glass, and it'll leave a permanent scratch in the glass. So you don't want to just take this and rub it on your window. Here's some common elements, or common things. Your fingernail is at a 2.5, so we use that as a way. If you can scratch something with your fingernail, you know that your fingernail is harder than it. So it would be talc or gypsum or something in a 1 or 2 range. We can use a penny because it's a 3.5, or an iron nail, a steel file, or a streak plate is at a 7. So here are those common minerals, and we will use those in the lab. The next thing is cleavage and fracture. Now, the cleavage is where it tends to split along smooth or flat surfaces, or cleavage planes. If you look at a mineral carefully and check for light reflecting off of flat surfaces, you can kind of see that. The other thing is you can hit it with a hammer, and if it breaks cleanly along regular flat surfaces, then it cleaves. So an example would be something like this, where if you were to break it, you see these really perfect planes where they break. This mica, when it breaks into nice thin sheets, nice flat, perfectly flat sheets, as opposed to something like this that is all uneven all the way around. So that would be considered fracture. So when it breaks into uneven surfaces. So tendency of a mineral to split along those flat surfaces can break down minerals and help us to identify them even more. We're going to use all these characteristics to help us narrow down what the mineral is so that we can identify it. And once we know what the mineral is, then we can have a better idea of how it formed, because different characteristics in the earth bring out these different minerals. So different elements have to exist, and different temperatures, different pressures to create these different minerals. So that's fracture again, that's cleavage. And then there's just one other is the specific gravity, which is basically a fancy way of saying density. Something that's really dense has a high specific gravity. It's the ratio between its weight and the weight of an equal amount of water. So you're just comparing it to the density of water, which is 1. So if it's got a high specific gravity, it's got a high density. If it's got a low specific gravity, it's got a low density. And there's a mineral called galena that has a very high specific gravity, and I'll show you a sample of that, and you can really tell it has a lot of heft to it. There's some other properties that we'll talk about, and I'll show you in the lab, that are things like salty taste. Now I want to be very clear, do not ever taste any mineral unless you have a really good sense of what it might be. Don't ever taste any of the minerals in the lab, please, because you may be tasting something that until you get better at it, you're not going to be able to distinguish which ones might have a salty taste or what might not. Magnetite, you can have a magnet, sometimes they're attracted to it. Calcite has something called double refraction, and I'll show you that in class and in lab. And it also bubbles with acid, the acid test that many of you have been dying to do. The acid test, you take a little bit of hydrochloric acid, you put it on the mineral, and it will bubble up like this when it reacts with that mineral. So that's all for now. We'll get to the second part of the notes, the rest of the notes on the other pages another time. So don't worry about that. I'll get to those at another point. So that's all for now.